So we're going to start with a little bit of a history lesson. And we're going to focus on generative AI. So generative AI became a thing in 2017 back over here. And that was with the launch of something called transformers, which essentially enabled what we see today in ChatGPT or Gemini. But for many years, they were pretty small. So what the scale is on the side is ostensibly the size of these different models, the parameters that went into them. And so it's pretty steady Eddie for a couple of years. And then suddenly there was a bit of a bump in January 2020 with a model that Microsoft had created. And very quickly, there was another bump in the same year with GPT-3. So this wasn't the same model as what launched in the end of the year that kind of went out to the public. But you can see the jump in terms of the size of the model. And then if we look at today, that jump, that GPT-3, it is minuscule compared to the models that we see. In April of 2023, GPT-4 came into public use, and that was 10 times bigger at 1.75 trillion parameters. And as we look at today, there are so many more models, different sizes, different locations. And if you scan this QR code, it'll give you the underlying data that the calculations that led to this. But what's also interesting is that we're going to expect another bump in the next few months. So planned for 2025, and in some cases sooner, based on what these technology organizations have announced. We're going to see OpenAI Orion, which is, again, imagine a bump where this thing becomes 10, maybe 100 times bigger in terms of compute. Google Gemini 2.0, Claude Opus 3.5, and then Elon Musk's Grok 3 is supposed to be due for the end of the year. Now, what does that all mean in terms of bigger? Is it necessarily better? What it means is there's more compute, there are more parameters, it can understand better patterns, and it can do more complex things based on that size. And so if we look at that evolution from GPT-4, which is what you see in ChatGPT right now, it's gotten way better at math. It went from 13.4% accuracy to the new model, which is still experimental and not largely released, is now 83% accurate. Coding has jumped from 11% to nearly 90% accuracy. But here's where it gets kind of interesting, is the ability to answer PhD level questions has certainly seen a bump, but more than a person. So human experts' ability to answer PhD level science question has now been eclipsed by these O1 models. And again, this is still Gen 2, and we're expecting Gen 3 in the coming months.
But it's good to take a step back and actually talk about what is AI and what are we all really referring to when we talk about transformers and we talk about generative AI. So at the essence or the simple definition is AI is there as a simulation of human intelligence processed by computers and machines. Simple enough, it's there to mimic our reasoning capabilities. But how does it work? And the best definition I heard recently, which was imagine understanding the connection between all pieces of data without needing the data. So I was started asking myself when I was getting into AI, how can an LLM or a large language model sitting on my computer with no access to the internet, no access to a database, know how old Albert Einstein is? Like, this is just crazy that this black box exists that just knows these things. It doesn't have a database. It has no internet connection. So I did a lot of research into understanding what are transformers and how does the technology work. And really, it's about the connection of information and the power of those connections. So it's not a data set, it's the relationship of each of those elements together. Imagine having every letter of the alphabet, but because you understand the relationship of all those letters, you can now understand you can create any word in the dictionary. Or another good example was someone saying, what about a chef? So a chef has been trained for 30 years on every ingredient, on every cooking utensil, on every kitchen. So if someone were to sit down and ask a chef something, it's not that they have a database or they go look at Google. They simply have intuitive knowledge through years of understanding the relationships of all of these different ingredients and products and temperatures and skill sets that lets them create any dish or combination of dish, right? So when you look at AI, It's not about a database. It's about an understanding of the relationship of information. And then that goes up from relationship of words to relationship of concepts, et cetera, as those ideas get bigger and bigger. So what are some of the elements that make up these AIs? So part of it is the large language model. So you have some key contenders out there, whether that's OpenAI, which most people are familiar with in terms of ChatGPT. You've got Claude Sonnet, which is fantastic, has a really high reasoning factor. You've got Google's Gemini, which it's kind of called to fame as its 2 million context window. But there's new runners every time, whether it's open source systems like Llama from Facebook or other competitors that are coming up that are constantly kind of drive. So what you see are all of these competitors hitting this LLM marketplace with this constant push to who has the best reasoning, who has the best capability, all while trying to drive costs down because that's a key driver in terms of using these systems. So it's a really big ecosystem of LLMs, and you could self-host them, you can train them. But Barry once said that it's kind of like energy. You can get energy from a bunch of different sources, and they all have unique benefits to them. But really, it's a fairly large marketplace of LLMs. Then you have the idea of being multimodal. What multimodal means, first we start with content. Again, LLMs were focused on generating words, scripts, predicting the next word that you needed, predicting the right reply to a sentence or a question. And now we're getting into images, we're getting into video, we're getting into audio, we're getting into 3D, we're getting into code, we're getting into all these things so that these LLMs have a lot more capability in terms of reasoning and understanding. You can give an LLM a picture and it understands intuitively what that picture is. They've even done examples where they've taken humans against AI and said, can you see the difference between these images? A good one is there's a cat with an orange in it sitting on a bed, but it looks a lot like an egg. And 5 years ago, or 3 years ago, sorry, an LLM would have said that was an egg. But now it's like, no, 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 that's a cat and that's an orange. But then it goes further. It's like, well, that's actually a tangerine. And that's actually this type of a cat, which again is more than a human would be able to understand. A recent story that I had a plant in my backyard. So I pulled out GPT on my phone. I took a picture of it. It looked like poison ivy. And GPT was like, no, 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 that is English ivy, commonly mistaken for poison ivy. And I was like, okay, still looks a lot like poison ivy. So you're going to take another two pictures. So about 3 seconds later, or three micro conversations, it was like, no, 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 English ivy, you're okay. It was right. So now having all these different modals really do help these LLMs to communicate and function in a whole new way. So what is the future of AI? A lot of people talk about agentic AI. And what agentic AI really is, it's the autonomous decision making of AI systems and focused on goal orientation. So it's giving AI a task or an agent a task, and we'll get into agents. But it's knowing that that agent is now going to work with other agents. It's also going to do research. It's going to have plugins into Google. It's going to have other functions where they're going to work like a microcosm of a team, and then they're going to come back with a decision. They're even going to do their own QA. So the difference is now I'm able to say, hey, can you go do this thing and give a very small task? And agents are going to start to say, well, the user asked for this. What do you think? And they start to communicate back and forth and enhance your prompt. And then they start to divvy up that prompt into tasks. And then multiple AI agents will go do those tasks and bring that back. And there's an agent that's in charge of vetting all the information that comes back and then validating that against, real sources, or validating that against the user's original intent. All these things come back and then give you the answer. Some of the new examples of agentic workflows are Claude getting access to a computer interface where now you can ask an agent to go search something on the web and it will go to Google on its own. It knows that, it types in the search, it does the research and can give you a summary of a paper. There's a good example where an agency used Claude to buy a product on Amazon and to buy a product on Walmart, then take screen grabs as it was doing it, then create a user experience report at the end to dictate which one was better and why it was better. But you literally saw the computer doing all this work autonomously, everything from going to finding the platforms to searching for the products on the platforms to reading the reviews, looking through multiple pictures, and then creating the summary, adding to cart, all that without any human interaction whatsoever. So as you start to think about the future, it's really about these agents having more autonomy and starting to work together to have a larger impact overall on AI. Anything I missed, Barry?
What we want to do now is start to walk through. So even though we are called Auto Agentic, one of the things that we're not fully at is that fully automated stage yet. But this is the direction that we're moving in. The one thing that I'd add, Mike, is maybe talk a little bit, we're going to be introducing For instance, and one of the things that I'll do real quick is I'm going to share my screen just so that way I can kind of highlight a few things. Uh, we currently have 6 agents. We've got a sales manager, we've got a budget and forecasting analyst. Ben, Zoe is our data analyst, Aaron is our HR expert, Alex is our growth marketing strategist, and Jesse is a legal assistant who can assist with contract IP and other legal matters. This is just the beginning, though. Maybe if you could explain, Mike, where we're heading in terms of where we are today with Auto Agentic and how we're going to be moving towards this larger, broader notion of true agentic AI.
Yeah, absolutely. So the first part of looking at these agents is really focusing on the human task and the human problems, really bringing a practical approach to AI. So what we've done is built agents that represent real people with real problems and real skill sets. So we sit down with those real people and then we talk to them and we understand their workflow, what their backgrounds are, what books they've read, really what makes them experts in their industry. And then we start to build these agents on top of that expertise. And if you think about, or if you've read about GPTs, which are agents on ChatGPT, they're about 500 characters long, or some are maybe 1,000. Agents on AutoAgentic are about 80,000 characters long. They're so much bigger because they have workflows built in, they have skill sets built in, they have reasoning built in, and they have like books of knowledge and frameworks all built into how they work. So first, it's about building those expertise so that you as an individual can interact with who is considered an expert in that industry. The other one is making these agents very industry specific. So not only are they experts in what they do, they're experts in that industry. And that could be tying in specific knowledge bases. It could be tying in specific databases that, again, help that agent have a better understanding of not just the industry itself and their expertise, but even live access to some pieces of data. So when you go to GPT and you say, hey, help me with this problem, it's coming at it from every angle because it has no context of who you are, has no idea what industry you're in, it has no idea who it should be in terms of the level. Should it be speaking at a university level or a college level? Should it be coming at it from an expert level or a novice level? All these things become arbitrary to it. So it just kind of shoots at its best guess at an answer. Versus with these agents, it knows who it is. And therefore, it knows when you're asking a question, you're asking for its perspective. So it can translate that as an expert to say, well, this is what I would do, and this is how I would approach that. So it's a really big difference. Going back to Barry's idea around energy, the LLM is the energy that powers the agents, but the agents is the intelligence. It's that expert level, whether that's the expertise in its capabilities or the expert in the industry and the combination thereof. So the future of where Auto Agentic is going to be adding more agents so that, again, more people within dealerships have access to agents that can help them do their jobs better, but also agents that you might not generally have access to, like a legal representative that you can ask questions to or say, hey, what will be the process here or the policy here? After that, it's going more into that agentic idea where we're looking at building a plugin that can sit in your monitor or in your browser where it can help you fill in an email. So it can work alongside you as a user, having direct access to your platform if you approve its access. So we're working on all the cyber requirements around what can it see, when is it allowed to see, what is the process of that to make sure that everything follows to our data and privacy requirements. But again, it goes from having to copy and paste it from a conversation to having it enter it directly into an email or a communication to a potential client.